In this Research Methods Basics video, we are going to very briefly take a look at something that may make you slightly happy, because thanks to statisticians who do tons of tests all the time, we have something that makes understanding how confident we can be that a particular value falls in a certain place under a normal distribution much easier. Now here's what we know. We know that if we take a sample that is random and truly representative of the population that we're interested in. Now, the population could be events, could be actual individuals, but if it's random and truly representative of the population, then whatever we're interested in studying, the type of event, the number of events, the probability that a person or a group of people engage in certain behavior, we can sample over and over and over again. And as long as our samples have a sample size greater than or equal to 30, meaning it's a larger sample, we can be relatively certain what our z-scores are going to be. Why? Because if our samples are random and actually representative of the population, then eventually they will all converge into the standard normal curve. So since all of these different samples can converge into this standard normal distribution, where our population mean is 0 and the standard deviations are 1, we can use what in statistics we refer to as z-critical values. Now, really, what statisticians should have just said is, hey, criminology, criminal justice majors, if you are working with actually random representative samples of the population, make sure you memorize the following critical values. So the following z-scores. These z-scores are used as a way for us to present the level of confidence that we have that a particular value, a particular x value, falls within a range under the standard normal distribution. So if we want our level of confidence to be 80%, where we could say we're 80% confident that whatever the value is falls where we're telling you, then the z-critical value is 1.28. Now, I'll draw this out so you understand it better in just a second. If we want our level of confidence to be 90%, if we want to be 90% confident, then the z-critical value we use is 1.645. 95% is 1.96. And 99% is 2.575. In most social science, particularly social science that gets published in peer-reviewed journals, we're really most interested in this 0.99 level of confidence. And we tend to consider the 0.95 level of confidence as nearing a significant value. All right, so let's see here. If we are 80% sure, I'm going to make this one yellow. If we're 80% sure that, let's say, the sample mean that we've been looking at falls between, we can be 80% sure if our sample mean, let's say our sample mean is right here. We're just going to make something up. Then we're going to use z-critical values, 1.28, probably about here. And a negative 1.28, about here. We can be 80% sure that our sample mean falls within 1.28 standard deviations of the mean. If we want to be 95% confident, use blue, then our z-critical values tell us to go to 1.96, which is probably about here. And on the negative side, right about here. We can find our sample mean, and if it falls between negative 1.96 and positive 1.96, we can say that our sample mean, with 95% confidence, our sample mean falls between 1.96 standard deviations of the mean. If we want to look for something that's really significant, we're after values that are way out here. Things that couldn't just happen by chance. So what we are hoping to find most often are not values that we could just randomly pick out of the bucket. The values we could randomly pick out of the bucket are any of these values where most of our observations fall. So we have these z-critical values. But what would be awesome is, let's say we are hoping to find that an individual observation or an individual X falls somewhere out here. This is when our observation reaches what we call statistical significance. And thanks to the Central Limit Theorem, the idea that we could take hundreds of thousands of samples, and if they're actually random samples and they represent the population that we're interested in, we can rely on what we know about the Central Limit Theorem, that it'll all eventually fall into a standard normal distribution, to calculate a value or set of values. We could have one down here too. that are less likely to occur by chance. They're less likely to just be random. Instead, they're statistically significant. And we'll get to that in a later video. But for now, criminology, criminal justice majors, or anyone working on quantitative research particularly, commit these Z critical values to memory.